6.1 Polygon Angle Sum Theorems. The sum of the measures of the interior angles of an n-gon, which means n is the number of sides, it could be any size polygon depending on the number of sides. Well, the sum of the interior angles is equal to n minus 2 times 180. So in order to find the interior angle sum of a polygon, you have to know how many sides it has. So in example 1, our polygon has 4 sides. So to find its sum, or angle sum, we're going to take 4 minus 2 times 180. In this case, when we do this, we get that the interior angle sum of this polygon is 360 degrees. In question 2, we're dealing with a hexagon. A hexagon means it has 6 sides, so that means n is 6 in this case. So to find its sum, we're going to take 6 minus 2 times 180. And when we multiply that out, we get that the hexagon has an interior angle sum of 720. What is the sum of the interior angle measures of a pentagon? Well, a pentagon has 5 sides, so that means n equals 5. So we're taking 5 minus 2 times 180. Multiply it out, we get that a pentagon has an interior angle sum of 540. What is the sum of the interior angle measures of a heptagon? Heptagon is 7 sides, so that's going to be 7 minus 2 times 180, which in this case is 900. And the next is, what is the interior interior angle measure sum of a 17agon? This just means a shape with 17 sides. So n in this case, pretty easy, 17. So we're taking 17 minus 2 times 180. And in this case, our interior angle sum is 2,700. An equilateral polygon is a polygon where all of the sides are congruent. An equiangular polygon is a polygon where the angles are congruent. And then a regular polygon contains both properties of equilateral and equiangular, meaning that both its angles inside and all of its sides are the same. So all the sides would be the same, and then all of the interior angles would also be the same. To find the measure of each interior angle of a regular polygon, you're going to use the formula n minus 2 times 180 divided by n. So you're taking the number of sides minus 2, timesing it by 180, and then dividing by the number of sides to find a single individual angle inside that polygon. And this works for regular polygons. So what is the measure of one angle of a regular hexagon? Well, a hexagon has 6 sides, so n equals 6. So we're going to plug that in and see what we get. So we've got 6 minus 2 times 180 divided by 6. So on the top, we get 720. On the bottom, we still have 6. So each angle inside of that regular hexagon has a measure of 120 degrees. What is the measure of one angle of a regular nonagon? Nonagon means the sides it has 9. So we're taking 9 minus 2 times 180 divided by 9. When you multiply the top out and then divide by the bottom, you get that each angle has a measure of 140 degrees. And then question 2, an 18agon, they want one of the angles inside of the regular 18agon, so that means n in this case is 18. So we just plug it in. We've got 18 minus 2 times 180 over 18. When you multiply out the top and then divide by the bottom, you get that every angle inside of that polygon has a measure of 160. Here we want to find the measures of the indicated angles for each polygon. And in order to do that, we need to find the angle sum of the polygon first, and then kind of work backwards. So this particular polygon has 5 sides. So n in this case is 5. So we're going to go ahead and find the sum of all of the angles. So 5 minus 2 times 180, which is going to give us 540. And we're going to take that information and we're going to set all of the angles we know equal to 540 and then we'll include y as well. So right now we know that we should have 90 plus 110 plus 120 plus 150 plus y equals 540. And so the key in this case is we want to go ahead and subtract all of these angles to the other side, so that way we're left with just y. And when we do that, we get y equals 70 degrees. Same thing here. We have 1, 2, 3, 4, 5 sides. So that means our angle sum we already know is going to be 540, just like the last problem. So we're going to take everything we know and set equal to 540. So 106, 94, 135, plus x plus 5 equals 540. We just want to combine like terms, so we'll take the constants, and we've got 340. We'll add the two x's together to get 2x equals 540. We'll subtract 340 to the other side. You get 2x equals 200. So in that case, that means x equals 100. And if x equals 100, we know that this angle here is 105, and this one is just 100. Theorem 6.2, Polygon Exterior Angle Sum Theorem. The sum of the measures of the exterior angles of a polygon, one at each vertex, which is a key here, is 360. So if you add up all of the exterior angles of a polygon where you have one angle per vertex, they're always going to add up to be 360. When you're dealing with irregular polygons, you have to know at least the interior angles in order to find your exterior angle measures. But when you're dealing with a regular polygon, you do not need to know these. You can actually find these pretty easily using the things we already know. So what is the measure of an exterior angle of a regular nonagon? So think about how we find the interior angle of a regular polygon. Well, we would take n minus 2 times 180 divided by the number of sides. That would give us an interior angle. Well, this is actually way easier. If it's regular, you don't even need to do all that. If you're looking for the exterior angle of a regular nonagon, all you have to do is take 360 divided by the number of sides, because all of the interior angles are the exact same measure, and the exterior angles all have to add up to 360. The only way they're going to add up to 360 is if they're all the same as well. So we take the 9 exterior angles, and we're dividing 360 by those, and we get that every exterior angle of the regular nonagon is 40 degrees. What is the measure of angle 1 in a regular octagon? So this is a regular octagon. We know all of these angles outside here add up to 360, and there's 8 of them. So we'll take 360 divided by 8, and we get that every angle here is 45 degrees, including angle 1. Find the missing angle measures. And so this is just some practice. So in this case, we've got 1, 2, 3, 4, 5, 6 sides. So n is 6. We'll find our sum first, n minus 2 times 180. That's going to tell us that our angle sum is 720. So we're going to take up and add everything together. So we've got 4 individual x's plus 2 of the x minus 6's. So that's 2x minus 12 equals 720. We can clean this up a little bit. So we've got 6x minus 12 equals 720. We'll subtract, or we'll add 12 to both sides. We got 6x equals 732. Divide by 6. X in this case is 122. So that means that these individual x angles are 122 degrees, where the two side ones are 116. All right, here we can just use some of our angle sum theorem and some just basic knowledge that we have. Like finding the measure of x is easy. This is a linear pair. So we'll take 180 minus 70 should give us x. So in this case, x equals 110. y, same idea, linear pair. So to find y, you take 180 minus 78. You're going to get y to equal 102. And then to find z, we know that all of the angles inside of this four-sided shape should add up to 360. So we're going to subtract all of the angles we know, including the 110 for the x here, from 360, and we should get z equals 82 degrees.